Are you here?
Yeah.
Okay, you can start in 5 minutes. I just make sure that if you have any question about if you have any question about the homework and the midterm, you can just go to directly talk to the home. And I hope like the old scope can be updated in next week.
All right. So I'm here to give you the answer of our midterm. Let me share my screen first. Okay. Can everybody see my screen?
Yes, I can see. Thanks.
Okay. So let's start with our midterm. Here I will give you the answer for the midterm for your reference. Okay. At first for the first question, we need to calculate the result of the we need to do some calculation. Here here's the question. Your question may be a bit different from this one, but kind of pretty similar. Here I will give you the answer. For the first one, we can just do the calculation. The first one is 32 mod 3 equal to 1, and 64 mod 3 equal to 2, and 128 128 mod 3 equal to, let's say, it's 2. So the result is it will be 1 times 2 times 2 mod 3 and equal to 1. And the second one is 2 power 100 mod 13. For this one, we need to convert it to. We need to use some tricky calculation. Here, at first, we need to notice that. At first, we need to notice that 2 power 4 equal to 16, and 16 mod 13 equal to 3, and 2 power 100 equal to 2 power 4 and power 25. And we mod 13, then we know it equal to 3 power 25 mod 13. Sorry. And when we get here, we also need to notice that 3 power 3 equal to 27, and 27 mod 13 equal to 1, and 3 power 25 equal to 3 power 3, and it's 8 and times 3. Then we know it is 1 power 8 times 3 mod 13 and equal to 3. This is for the second question. And then let's go on. Let's move to next one. Next one is 3 power 33 mode 83. Here we need to know that 3 power 4 equal to 81 and equal to minus 2 mode 83. And then we get this 3 power 33 equal to 3 power 4 and power 8 times 3 in mode 83. And then we know it's minus 2 power 8 times 3 mode 83 and equal to 256 times 3 83 and then now we can directly calculate it and equal to let me see, 167 times 3 mode 83 equal to 21. That's all. This is for the third part of the first question. Any questions for this calculation?
How did you get 7 from?
This 7 from is that 246 mode 83 because this is you can directly calculate it. Just 246 equal to 83. Let me see. Equal to 4 times 3 times 83. This is, let me see, 249 and plus x. Then we know x equal to 7. So this 256 mode 83 is 7.
Okay, thanks.
Okay, now let's move to the next one. Next one we need to do the encryption and decryption using RIC algorithm. Here we are given P and Q, so we can directly calculate N. N equal to P times Q, which is 33. 33. And phi N is P minus 1 and Q minus 1, which is 20. And here we get D. So to encrypt it, we need to calculate E and E equal to and here we need to make E times D mode phi n equal to 1. Here, because here is D equal to 7. For here we can calculate it. You calculate E by just trying something like train 1, train 2, and train 3. When we train E equal to 3, we get E equal to 3, we get that E times D equals 21, equal to 1 mode 20. So then we get this E equal to 3. And next step is after we get this E, and the next step is to increase. To increase, we just use this X message X. Message power E, which is 5 power 3, and then mode N, which is 125 mode 33, and it is 26. And then we do the decryption. And the decryption is 26 power 7 mode 33, and the result is 5. And that's all for the first question. Okay. And now let's move to the second question. The second question is we need to calculate the local sensitivity, and for the function is median. First, we sort the salaries. The salaries is it's 10,000 and 20 and 50. And next one is also 50. And next one is 60. And next one is 80,000. And after we get this this series, after we started this series, we can calculate the median. Now the median is average of these two, so it's 550,000. And to make it, because we are calculating the local sensitivity, then we need to make the median change the most. Here we have actually by observation we can find only if we change the largest one or the lowest salary, we can actually make the change be the most. Either change the lowest salary to a larger one, or change the largest salary to a lower one. Here we can try to modify it. And first of all, we try to modify this from this 10,000 to the maximum. For example, here it is 100,000. Then we get the result is 20 and 50 and 50 and 60 and 80 and 100. Oh, sorry. And now what is the median? The median is the average of these two, so it's 55. And then we can try to modify this 80 to a smaller one. Then it is here our range is from from 1,000 to 100,000. So we can modify it to the lowest one. So it is 1,000 and 10 and 20 and 50 and 50 and 60. And now we can find the median is the average of these two. So it is 35,000. And we know here we get the maximum change of this median after modification. And actually we have no need to modify this 80,000 to the smallest one. We can modify it to the any number if it's less or equal to 20,000. Then we can get this one. And the local sensitivity will be 15,000. This is the answer for the second question. To calculate the local sensitivity. Okay, I think that's okay. Okay, now let's move to question 3. The question 3 is also we need to calculate with for the f equal to median and k equal to 2 to calculate LSF. And we have the from slides we have the formula. This one. We have this formula. So we can simply following the formula and do the calculation. For your set, you will find that the data is a bit different from what I'm showing here, and the k maybe also either be 2 or 3 or something else. And it's okay, but if you following this formula, you will get the result. That's the offer for this question is just you following this formula. That's all. Do you need me to calculate the all of them step by step, or we can go to next question? In this, if you know this formula, you will know how to calculate it. And let's move to next question. The next question is to marrying the similarity of the graphs. You may have different graphs. For example, these two. Let's use these two as an example and do the calculate it. For the first one, according to the definition of mirroring of the similarity of graphs, we can find that for D there's no common connecting mapped nodes to D. So the similarity from D to all the for either G or K or L will be 0, and also same for E and F. So for the first graph, the similarity of all the other nodes are 0. And then let's calculate the second one. The second one, we find that for the node D and F and K and L are pretty the same. But for the node E and G, we think that we can find that only G only G and G and E share the mapped node, and then we know the score. Let me see. E and G will be square 3 and 1 and equal to and score. A score for all the others will be 0. This is for the second graph. And this is the answer for the let's see, for the fourth question.
Actually, I have a question about this question. Yeah.
Yeah.
So basically, we have a score from E to J. So because it's the top score in this graph, so I think we can build a pair from E to J because they're the top score.
Yeah.
So then the E to J are mapped. That means we still have a score from D to K because D is it has a link to E and the K has a link to J. That's my answer. So I think E can map with J. So I calculate the score from D to K and F to K. So is that correct, or does it have some problem about my yeah?
No, but here we only use the given map node to calculate the similarity. We cannot use this later we mapped it and then we consider it as map node. No, we cannot do that.
Okay.
Okay. This is the fourth question, and now let's move to the fifth one. The fifth one is about the Laplace mechanism. And don't worry if you point out the score of like E to G, you already get some partial credit, and for some others, maybe you cannot get full, but you still get partial credit. And for the question 5, Laplace mechanism. The Laplace mechanism, we have we get given this question, and we also have the formula from our slides. And the slides, and from the slides, yeah, from this formula we can get that now we have this KRY. We can get this here Y A. Actually it should be because here is 0.98, and then it is it should be less than. It's larger than. Let me see. This is 4,000, and so this one is will be 0.2. So it will be 4,000. The two families, and divided by 2%, 0.2, and make sure it is make sure it make sure it is less or equal to to 8%. And then we can find that and then we all know this x. Then it will be sorry, it should be larger. Right. This is for another question. Okay. For this one is okay. This one should be 2%, and here it is larger than ln this one. From tomorrow we should get this equation, and then we get this x equal to ln is 4,000 divided by 0.02, and actually this x is will equal to what? And then it should equal to 12.2. And also you can find this formula in the slides differential privacy basic at the page 70. And the second question, is it a smaller error for a large population, say let us say 300,000? The answer is yes, it's a smaller error for a large population. This is the answer for the fifth question, Laplace mechanism. In the here is kind of small calculation, but in the next question, let's move to the sixth question. In the sixth question, there may be a little bit more calculation about this. Okay. From your side, you may get different list at here from what I'm showing here. And for this question, what we need to do is to apply the formula. We apply this formula, which is also given in the slides. And let's see. It is in the slides graph annotation 49, page 49. And if you're following this, this formula, you should get the answer of yeah. Here's the answer for the question for the first part. The first part is for the first part. At first we calculate the right part of this equation. The right part, let's do it. Yeah. The right part is for I equal to it's 1 and 2 and 3 and 4. for I equal to from 1 to 10, we can calculate this L minus 1 plus sigma sum I equal to L plus 1 to N, meaning L and DI, and it will equal to let's see, first one is 9 and 18 and 26 and 34 and 41 and 47 and 53 and 62 and 74 and 90. The right part of this equation it will be equal to like here. This is for the first one, for the first part, and for the left part is sum of I equal to 1 to L DI, and it is equal to 9, 17, 25, and 33, and 40, and 47, and 53, and 58, and 62, and 64. Now we need to compare these two of the left part and the right part. We find all the left part are smaller than the right part, so it satisfies the degree. So it is degree sequence for a graph. So the first one it satisfies, and then let's calculate the second one. The second one is that the left part I equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the right part will equal to similar, because here's the 9 and 18 and let's see, 26 and 33 and 40 and 46. And when you are doing the exam, you can calculate the left part and right part simultaneously, and also you can calculate the left part. Your left part will be equal to 9 and 17 and 25 and 33 and 41. Sorry. When you calculate here, you'll find here we find the left part is already larger than the right part. So the second one doesn't have a graph for this degree sequence. Okay, that's all for the for this question. The answer for this question. Any questions about this answer? Okay, now let's move to the next one. So the last question. The last question. The last question is a bit more complex. For the last question, we are asked to calculate to make this degree sequence k degree anonymity where k equals 3. For this question, everybody get the same problem, problem, and no problem. Everybody get the same question for the last one. For this one, you can modify it following some other method. But here I will give you a solution with optimal cost for making it k degree anonymity. And here we are using here we are using the dynamic algorithm. And for here, we are giving these two formula to calculate IIG and DA1I. The first formula IIG means to make the data the degree from ith to jth to the same one, and also make sure the modification cost has the minimum cost. So here, first we can we can put down this sheet and make calculate this I1I. And to calculate this I1I, we can use this formula. And to calculate it, for the first one, it is 0. And for the second one, it is 1. And third one is also 1. And also when calculating it, if we using the definition of this formula, we can calculate it easier. That means the formula IIG is to calculate the minimum cost to make from ith to jth item to the same group. For example, for the first two, I12 means the cost of making 7 and 6 to the same group. We can either make it to 7 or make all of them to 6, and the costs are all 1. And for the second one, I13 means to make first 3, 7, 6, 6 to the same group. To the same group, we can either make all of them to 7 or all of them to 6. If we make all of them to 7, then the cost is 2. If we make all of them to 6, then the cost is 1. We select the minimum one. So the cost, the I13 is also 1. Same for I14. I14 is to make 7, 6, 6, 5 to the same group. We can either make them all to 7 or all to 6 or all to 5. If we make all of them to 7, then the cost will be 4. If we make all of them to 6, then the cost will be 2. And if to make it all of them to 5, then the cost will be 4. We select this minimum one. So here we want to make all of them to 2. To 6. So the cost will be 2. For the same way, we can calculate. We can calculate all the rest in this table. Let me see. And here the I1I is 0, 1, 1, 2, 3, 5, and 8 and 11 and 15. And after calculating this I1, we can calculate this dA. This dA1I. dA1I means the minimum cost of making the given sequence from 1 to I satisfies this key degree anonymity. And when calculating this dA, we can also find how to modify this degree. So now let's start calculating it. And at first for this dA, when I is less than not equal, when I is less than 2k, then d1I equal to I1I. So 2k here is 6. So from 1 to 5, we can directly put it down. 0, 1, 1, 2, 3. And then we calculate this dA1, let's see, 6. D1 6 is, let's put down this this formula. So it is the minimum of minimum. So k equals to 3, less than t, and less than. So I minus k. So here is 6. So 6 minus 3 is also 3. Of here is dA1t, and here t equals 3. Here t, because t and here it can only be 3, so it is 3, and it's plus I 3 plus t plus 1, so it is 4 to 6, and I 1 6. So now let's calculate it. For the first one, D13, we can find it from the table. It's 1, and I46. For I46, we can call it following the previous formula, and it's to make this 5 5 4 to the same one. We make them all of them to 5, and the result result of this I46 is 1, and it equal to mean. Here is 1 plus 1, and it's 2, and I16 is 5. And DA6 is 2. And now let's calculate this DA17. Following the same way, we can calculate. We can know that it is equal to median t equal to, here it's 3 less than t, and less than, here it's 7 minus 3, so it's 4. So t can either equal to 3 or 4. And dA1t plus I t plus 1 and I, and I17. Following the similar way, we can get the result is it is equal to, let me see, equal to 5. And DA17 we can call it for pretty the same medium t equal to 3, 4, and 5, and 1, 8. And also for the last one, is actually only the last one is what we really need. 9 equal to medium t equal to 3 or 4 or 5 or 6. And here is dA or 1t plus I t plus 1 I and I 1 9. Okay, looks it's not enough. We need to. Okay. Now let's go to move to the next page. Here we get this DA19. To following this formula, we have this medium of 1t equal to 3. It's DA1 3 and plus I 4 to 9. Or t equal to 4, dA 1 4 plus I 5 9, or dA 1 5 plus I what's this? I 6 9, or dA 1 6 plus I 7 9. This is the first part, and then the last part is I 1 9. Okay, now let's calculate it. The calculating is medium. The first part we can find it from the table. It is 1 plus from make I 4 to 9 to the same one. So to make it from 4 to 9 to the same one, it's 5 5 4 2 2 1. 5 5 4 2 2 1. To make it to the same one, let's make it 5. Make it 5, then the result will be let me see, 10. It will be like 11. And make it all of them to 4, then the result will be 1 2 will be 9. And make them all to 2. Let me see, it will be it is also 9. And make them all to 1. Definitely it's larger. It is larger than 9. So the small one is 9. So it's 1 plus 9. And the second one is DA1 4 and plus I 5 9. So it is 2 plus 6. And the third one is 3 plus 3. And the last one is DA1 6. We can find it from the table. It's 2. And I79. I79 is to make 2 to 1 to the same one. So we can always make them all to 2. And the cost will be 1. And the result is this 1 9. 1 9 is anyway, it's a large number. It's 15. So here we get this. The medium is 10 and 8, no, yes, and 6 and 3 and 15. We know here is equal to 3. So the minimum cost is 3. And now we have the process of how to get this 3. Let's tracking back to see how to achieve this minimum cost of 3. Here we can know it's 3 from here, and we know it's DA16 and I79. So then we know our first process is to make 7 and 9 to be the same group. And another one is to following the dividing method of how to get this DA16. Let me use another color. Here we get the first group. It's from 7th to 9th, and another part is from DA16. And how to get this? How to divide this? How to modify the from first one to sixth one? Let's go back to here. Here, let's see the this one, DA16, where it's using here. And to get this DA16 is 2. So it's from this 1 plus 1. Where's this 1 plus 1? So it's DA16 and I46. So now we get the another group. It's from 4 to 6. Then 4 to 6. And then let's see this DA1613, because we know when I less than 6, DA1I equal to I1I, so it is I13. Then we know then we know the last one is from 1 to 3. So now we get how to modify this degree sequence.
Bank. Hello.
Yeah, I think something wrong. I don't know.
Okay. It's like you are done, right?
Yeah.
Oh, okay. All right. Thank you. So, when will the results be released for both midterm and assignments?
Then maybe Professor Chang can answer. I don't know.
What's the question? I kind of missed. What's your question?
When we can go score about this test and the assignment 1?
I expect like the Peng will be posted on the this before next weekend.
Next
Can you
weekend.
do that?
Okay.
Yeah.
Are you still there? So Peng is already finished his talk.
I think he's disconnected. I don't know.
Okay. Okay. Yeah. So any more question? I'm here right now. So any more question regarding about this class? Feel free to ask. We have plenty of time. Or any suggestions? By the way, like if you haven't sent me the email about your presentation title, please let me know by today.